find myself a bit more space. Okay, so our function was n equal to 3 to the n minus 1. Okay, so we then say for our base case, okay, so let's, for example, say, okay, p of 1. We've already done this. We know this is true. That is equal to 2. Okay, so we are satisfied. Then we take our inductive step. Okay. And here, just to be clear, we change the variable for n from n to k. Just to be clear, we're in the inductive step. And we make the statement that this is true. Okay, so this will be true. Okay. However, what we want to prove is if we take a step forward, that this will also be true. Now, what we want to do here is then say, well, this will be, we look for all instances of k in our function, and we replace those, okay, with k plus 1. So k plus 1. So that's 3 to the power of k plus 1 minus 1. Now, our job here is to find some way back to the facts that we have already established, the facts that this is divisible by 2, and the fact that this is assumed to be true. So we can rely on this statement if we can find it as well. Okay, from here on, these are all the fun parts. We then try to break this apart and find it in some format that we can see these facts. Okay, so 3 to the k plus 1. Well, we can say that this is 3 times 3 k minus 1. Okay, so I'm just taking that power and moving it here. Okay, then if this is 3 times k minus 1, okay, already here I can see, well, I'm getting towards my 3k minus 1, so that's good because that's something I want to get to. So if I keep this itself, split this 3 into 2, well, I can say this is going to be, well, 3 to the k plus 3 to the k plus 3 to the k minus 1. Okay, so again, that's just 3 times 3 to the k. I can break that apart. And then I could just say, well, if I take these, just summarize that, well, that's just 2 times 3 to the k plus 3 to the k minus 1. Okay, what have I shown at this point in time? Well, I've got to 3 to the k minus 1, which I know to be true. And then I have something else, 2 times 3 to the k. Irrespective of what 3 to the k might actually be, we have a factor of 2. So we know that this part is divisible by 2. That's already been, we've said that is true. And anything else has a factor of 2 as well. Okay, so we can be then quite satisfied that we have proven by induction that this is in fact true. Okay.